there are certain other options in the containers. That is, so if you remember, I was talking about how interactively you can get into the container. That is, if you use a Docker run command, it will not only create the container, but you will also be able to go inside it. So that is quite possible using the option -t and -i because you were able to interact with the container. But for some purpose, say you don't have to interact with the container and you want to run it as a background process. That means you want a machine or you want a container which has a separate operating system, but you don't want to get connected to it and just run some process inside it and it should be in the background. That means you want to create a container and the container should run something, whereas you don't want to connect to the container, but let the container run some command or some process inside the container and it should be running on the background. So if that is the scenario, then you should be creating the container as a demonized container, because in Unix or Linux, a daemon is referred as a process which runs in the background without any interaction with the standard input. That means you cannot, you know, basically access it in the command prompt. So to do such a kind of thing, now the same options, whatever that we run, should be tweaked little bit. That is, we ran docker run and we used -it, right? So instead of that, the difference would be we are going to use docker run, okay, and -d. Whereas if you say -it, only then you will be able to go inside the container and give some command so that you can enter. But if you see -d, then it will create a container, it will run, but it will be running on the backend. So you cannot access them. All right. So let's take an example and try to see how you can run a container in the backend as a daemon process. Now to do it, you need to run something, right? So what is that you're going to do? Now, if you remember in the previous example, I said you need two things to be passing to the docker run command. One is what is the image, and second thing is what is the environment that you're going to run. But now to show this example, I'm going to run a small shell script. So to run the shell script, I can still use bash or you can use any other shell like bourne again shell. Okay, so there are a lot of variables or there are a lot of shell environment using which you can run a shell script. So pretty much when you're using a shell script, there are two variables or the environment that you use quite popular. That is, one is bash and the other one is sh shell or bourne shell. Now, let us try to do the same thing. So let me connect. Okay, I'm already connected. Now, since I installed Docker as root, I'll just switch as root. Okay. And now, if you see, we have Docker installed, but Docker is not running. If you remember, because every time I stop my machine and try to reconnect it, the Docker process will not be running. So the first thing that I need to do is I need to ensure that Docker is running. So we'll say service docker start. Okay, so now Docker service is running and you can see that there's a daemon running. Okay, now once this is done, we are back and let's start running the container. Now, okay, so let me say docker run. I'm going to give some name for the container. Okay, so let me say name is August 22. Okay, and 2201 container. And here I'm not going to interact anything with it. So I'm just going to give -d, that is the daemon process. And then I'm saying, what is the image I have to use? And then I'm going to say, what is the entry point to that container? So that container has to have an environment to run something. So that environment is nothing but this sh. Now for this, I'm passing some options or a command. Whereas if you see, this itself is a shell script where it is running. Because just for some testing purpose, I'm using a small. So here. So I'm saying while true, which means this is going to run in an iterative mode or a loop. That is, it'll be keep on running it. Okay. So what I'm interested to do is I'm just interested to run some command. Okay. So I'm going to say hello students. Okay. Sleep one and done. So what exactly is this command doing? So if you see, so if I say while true, this is nothing but a specific iteration or a looping in shell script wherein you can run something again and again. Now, since I am saying while true, the condition will always be true, and this loop inside which whatever command that I'm going to give will be running always. So for those who don't know what is scripting, you don't have to worry. When we go through scripting, I'll be covering all this looping and we'll see the concept. But just for now, you take it as a small script which will be printing this command called echo hello students always, so that we can know something is happening inside the container. Okay, so sleep means it will print this. Okay, basically it will print this on the screen, and then it will wait for 1 second, and then it will print in the screen. So it will be keep on doing the same thing forever. Okay, so why did I do this way? To ensure that the container is running, and inside the container you are running some command. Okay, because in your production environment, you might be running some tasks there. Just to show as an example that we are running the container, and inside the container there is something happening. I'm just using this small example. So now if you run it, so what happened? Now as soon as you entered, the container was created. Okay, and this is the container ID, and it came out. This is because we didn't use hyphen what? We didn't use -int. That is the reason it didn't give us a interactive way under terminal to get into the container. Now, is the container running? You can simply run docker ps, and you see, yes, it is running, and this is the one that we have. But now we know that the container is running, but how do you know what is running inside it? Because we cannot access the container now, and at the same time, we cannot see whatever is happening inside it or whatever process that is running. So in those cases, when you have a daemon process running, that is a daemon container, but you want to know what is happening inside a container, then you can use an option called Docker logs and try to fetch all the information about what is happening inside the container. Like if we had a container, how it would have looked. As soon as you connected, you would have get some prompt, and whatever that you are running there, it would have been running, right? Now in the same way, if I had created a container with an interactive way, and in that, if I had run this command, suppose assume that I had created a container, and if I had run this, what would happen? You see, this would have been running the script like this, and you will get output like that, right? So this is what would be happening. But now the same would be still happening inside this new container, but it is running as a daemon process. So that is why we are not able to see it from our command prompt. So now, in order to know what is happening inside this container, that is inside the process, whatever it is happening, then you will use this command called docker logs. Okay. Now, when you say docker logs and the container ID, so you see what it does is it gives you the complete output of whatever has happened in the container until now in the process. Okay. But if you see, it might be a complete output and you are still seeing the output happening, right? But here it just gave you a output at that point of time. Whatever has happened, it will try to print it on your screen. But now, if you want to see what is currently happening, then along with the logs, you have to use a -f option. So what does -f does is it not gets every output from the whatever screen or whatever container that you're taking, but it will get you the latest output. And if you see the screen, it is still printing. That means as soon as something happens inside the container, that output will come here. Okay, so that is the difference between a logs command and logs -f. -f means it will not just print and leave. Whatever is the latest content, as soon as you get it inside the screen, that will be printed here. Okay, so this is how you can try to check what is happening inside a container and verify. At any point of time, if you want to stop it, just say Control C and it will stop printing the information of the log. Okay, so when do you run this daemon? Especially you want to run some tool or some script or some process and you don't want it to log in and run interactively. And that is when you simply create a daemon process and run. Now there are many examples where after some time I'll be showing you. One of them is like I said, if you want to use Jenkins, you want to install Jenkins is one way. If not, you can create a container which has Jenkins pre-installed. Now I am creating a container which will have a Jenkins where I can access, but I don't want to interact to it because my only requirement is to have a Docker container and have some tool inside it. So in that kind of cases, all you can do is you can simply run it as a daemon process so that you don't have it as a interactive. Because what will happen as soon as if you by mistake go as a interactive way, if you say exit, the container will stop and you cannot access whatever is running inside it, right? So that is when if you want something to be running inside the container and you want to access it, then you run it simply as a daemon container. Okay, fine. Now, suppose if there is a need where you want to inspect whatever is the container running, suppose you have many containers running. Okay, so in that case, how do you know what container is running, how much of utilization or the resource that is being taken? Then you can say docker top, and in the docker top you can say the container ID. So in our example, if I say docker top and the container ID, so you see docker top is nothing but a command similar to top on Linux. So on Linux, if you say top, okay, so this is a Linux machine. If I say top, what it does is top command gives you the list of top processes which is running on your operating system, which is consuming too much of resource or which is consuming the highest resource. So as the name says, it will give you the top list of those processes which are consuming the process in your machine. So it will give you the details of how much of RAM is utilized, how much of memory is utilized. Okay, so completely what is the load on the machine, all those details will be given. So in the same way, now if you see, even a container is acting as a operating system, right? So there are a lot of process running inside it. So if at any point of time, if I want to know what are the processes which are running inside the container taking highest resources, then you use Docker top. And now if you see, when you're running Docker top, it clearly says that there is a process called root which has been run, and the process that we are having is this script that we are running, which is the having the process ID of 1774, and now this is the one which is consuming the highest process. Okay, so like that you can also know what and all are the processes which are being utilized highly or which is taking high resources in your machine using the top, or that is Docker top command. So this is something exactly similar to top, but the difference is when you natively say top, it will give you a lot many information, and here this is not going to give you every information like the regular Linux top, but something similar wherein for this container, whatever processes that has been taking too much of resource. Okay, so every time you can run it. Okay, now, so we talk Docker processes, we saw daemon. Okay, now, so far, it's all about containers that we created. Now, many times, as I said, you would be having some container and you want someone to use the same container. So logically that is not possible. But what you can do is you can create a container based on another container. That means now, for example, let me create a container. Okay, so okay, let's create a container and let's start it in iterative mode. And I'll give the name as 02. Okay, so what we have done, we have created a container and we are inside it. Okay, and what is that container? This is the ID. That is what you can see it here also, which is acting as the name of the machine or the container. Whereas the container also has a name called August 2202 container. Now, here this is a Ubuntu based container or a machine, right? So what we can do is now you can install whatever things that you need here. Now that is one way for just for practice to understand it. What I'm going to do is I'm just going to create some sample file. Okay, so I'm going to say touch in the temp. I'm going to create this. Okay, just some file. Okay, so if you see in the temp, you will have one file that we have created. Okay, and now what I'm going to do is I've created a container. Okay, now whatever that I wanted to run in this or whatever I want to install, you can do it. Now once you have done, what is that we have to do is now I want to share my container with someone else, because that is the actual purpose of using a container, right? Because now if I am a developer, I might use my environment wherein I have installed something and have created whatever the specific environment that I need to run my application. That could be development or for some testing purpose. In the same way, a QA person also can create a container with whatever environment that he need. But now we should always be able to reuse this container. Now, if someone else comes and if they want to get the same thing done, then how is that you're going to use it? So that is when we should be able to use the same container or something similar to the container without any effort, because the actual purpose of container, as we were discussing in the first class, is reusing it. Because again, if I spend too much of time in doing the same thing, that is creating a container and installing everything, that is not going to be of much use. But if there is a way where from an existing container, if I can get all the details and create another container, and if I go inside the container, I should be getting everything whatever I had in my previous container. Okay, so that is what we are trying to do now. Okay, now for example, after creating this file, let me install something. So do we have Vim in this? Okay, so we don't have Vim. So let me, so in, like I said, every operating system has a separate package. Now, VIM is a editor using which you can create files and you can write some content inside that file and save the file in Unix. Just like how you have Notepad in Windows, in Unix or Linux, we have an editor called VI or VIM. Now, by default, it will not be available because if you remember, the image that we created or we are using is a base image and it doesn't have any much of the softwares that we have. So basically, when you're creating a container with a base image like this, you have to put all those installation or packages that you want to do. And now since we are using Ubuntu, for Ubuntu, the packager that we are going to use is apt-get. Whereas for CentOS, it was yum. So that keeps changing. Now here, okay. Anyways, if you want, you can install this, but okay. Now, this is not recognizing this because we still have to do some network connections. Now, I've not done. Okay, but anyway, let's not worry about it. So like this, once you create a container, you can install or put any software, you can put some files and whatever that you want, you can do. Now, right now, the only thing that I've done is I have created a simple file called August 22, right? So now what I'm interested is I need this to be used by someone else, or I want to use this container and I want to share this container with someone else. Now, logically, the container itself cannot be shared. But what we can do is now we can create a image based on this container. Now, just like how we used the Ubuntu image, what we can do is whatever the container that we created, we can create a image based on that. So when you create an image now, what is that image going to contain? So, so first, what is that we did? So we had a container, and in this container, we put Ubuntu as a base image, right? So we put Ubuntu as the base image. Now on top of that, we put one file, correct? So on top of that, I created one more layer, and in that layer is nothing but I added some file, right? So I created a file inside the temp called, okay, now this is what I created. Now this is the container. Now when you create an image out of it, what will happen is the image will get created, but if you see now, the image not only is going to contain Ubuntu, but it is also going to contain the what? This file also. So now the new container, whatever that you're going to create, will contain this base image, and on top of that it is also going to contain this particular file that you had inside it. Like that, whatever that you had as a layer inside this container, everything will come. So now using this, if you are creating another new container, okay, now say for example this was our what? August 2202 container, right? Now I created a new image. Let's say if we create a new image and I give some new name. Okay, so let's say this is the new image. Now from this, if I create another container, okay, and say let me name it as August 2203. Okay, this is our new container, and inside this, if I want to use this same image, now you are not only creating a container with the base image Ubuntu, but also getting all these layers, whatever that you had as this container as an image. So automatically, whatever that you had as a layer, in our case, this file will also be available. So now on top of this, whatever you want, you can start putting it as a layer. That is, you can install, you can run any process, you can create file, whatever that you want, you can do specific to this. Okay, so let us try to do the same. Now to do that, what is that you have to do is, first thing, you need to create a specific image from it. So to create a specific image, you have to use a command called docker commit. Okay, so docker commit means you are creating a new image based on the existing image. Okay, so for that, there are two ways of running the commit command. Now, if you say docker commit and a name of the container or the ID of the container, it will basically create an image. But if you see, again, when you don't give any other option and just the name of the container, then it is going to create an image based on some value or some name which randomly Docker uses. And if not, if you want to create a image name as you like, then along with the Docker commit and the container name, you have to just say the new image name, so that now you will also have the image with this specific name. Okay, and once this is done, what is the next thing that you can do? Simply you can do a docker run and use this image whatever that you have created. Okay, so now let us first try to do that. So we created a container with just some file, right? So once this is done, I'm going to simply come out of it. So I'm back to my host machine. Okay, now at any point of time, if you want to know what is the difference that you have done in the container, that means in the container, what is that we have done? So other than the base image, we had created one file, right? That is the layer that we have put on top of the Ubuntu. So now if you want to know, after creating a container based on a base image, what and all things that you have done or what and all layers that you have put, then you can use a command called docker diff. And for this, if you give the container name, okay, so here you see it says that basically we have appended or added a new file called container. So like this, any process, any file or any run application that you have installed or running, it will clearly say that what and all are the modifications that you have done on top of the base image from which you have created the container. Okay, so clearly it says that other than the Ubuntu standard image that you have created, on top of that, we have one layer called a file which we have created inside temp. Okay, so now let us try to create a image based on this. Okay, let me just clear the screen. So now, so we have this. Is it fine if I reduce the font, or you can still manage because few things are not coming? So is this font okay, or if I reduce it a little bit, is this font okay?
Okay.
Yeah, it is okay.
This is fine, right?
Yes.
Okay, now, okay, so we have one container here. Now, what is this container? Now we stopped this container, right? Pretty much. So that is why we don't see this in the normal PS. So I'm just running a Docker PS-a so that you'll getting everything. But still, if you see, this Docker 01 container is still running, because if you remember, I am just putting a echo statement or a statement to print hello students on the screen, and that would be still running because we didn't do anything to the container. But the second container that we created, we did the exit. That's the reason it came out. Okay. Now, in order to create an image out of a container, you have to say docker commit, okay, and then the container name. So, okay, now if you simply say this, now I created a image. Okay. Now, as I said, I didn't give any name to the image. So what you can do now is you can use that, but we don't know what is the name. So going back to the command called docker images. So what is this going to do? Docker images is going to give a list of all the images that is present in our machine or the Docker engine which we are running, right? So now if you see, until now, we had only one image called Ubuntu, which is the one which we downloaded it yesterday for the first time from the open source Docker registry. And from there, we were trying to use it. Correct? But now, along with that, you see, you have one more image that is available, and this is the image or the image ID. Now here in this image we don't have any specific name for that, so there is only the image ID that you have. So any point of time, if you created a image without a name, then you can have a name to it tagged, and to do that, simply use a command called docker tag new image ID and give a tag to it so that you can represent it with the name. So now if you say docker tag, tag means, again, what do you understand by tag? Tag is nothing but a label through which you can understand whatever that is present as in quick information, right? So when you go to any shop, pretty much any mall, you'll always have a tag which gives the details of the price and the details about the material. So in the same way, now a tag can be applied for an image as a quick reference to know what is it. So that is what the name that you're going to use. So now I'm going to give a name for this tag. So I'll say my first image. Okay. So once now you run the Docker image, you see it clearly says that name of the image is my first image. Okay, so this is the way that you can create, or simply when you're running the Docker commit, here you give a name. So now you see I created one more image. So like this, you can create as many images as you want from a container. Now here we got it, but still if you see, even though the content of the image is same, there are two separate images. Okay, so like this you can create as many images as you want. And now let us use this image to create a new container. So let me create docker run, and I'll say August 2203. Okay, and container -it so that it is interactive. And now you need to give the image name. So now let me use any one of this image. Okay, and we'll give a entry point. Okay, so now if you can see, I am inside this new container, correct? And now in this container, what is that operating system that you have? you can simply say etc os-release. It is Ubuntu. Okay, that is because this first image is created based on what? You have two things. That is, first you have a Ubuntu layer, and then on top of that you have one more file. So that is why by using this image, you are getting a Ubuntu operating system. And along with it, if we go inside the temp folder, and if you see, you will have this content, or if you have the same file here also. So that is the difference, wherein rather than directly using the container, you can create a image based on the container. And how do you do it? Using the commit. And when you create a image based on the container, whatever is existing in that container, everything will be stored as a layer inside this image. And when you create a new container based on this image, whatever is present will also be available here. But it is only from the image. Now, going forward, anything that I do specific to the previous container, it will not be available, but only at that point of time. Whatever that you created as an file or as an image, that is what you will be able to get. Say, for example, now I'm just coming out. Okay, so if you see, we had created all this three and we still have running this, right? Now, let me first start this container. So I'll say Docker start. Okay. And once you start, then you have to say Docker attach. Okay. So I'm now going inside it. So once you go, you can see the file here, right? Now here, let me put some content inside the file. Okay. I'll say this is August 2202 container. Okay, and I'm trying to put the content into this file. So now if you see, this file has some content called one line, which is nothing but this is August 2202. Correct? Now let me go to the other container. Okay, so this is the same machine, so I don't have to start the Docker now because it is not a separate machine. It is the same machine, but I have created a new terminal, and from that I'm trying to access. Okay, so now here, once again, if you say, so our 03 container is still not running. So let us do the same thing and bring that also up. So now I'll say Docker start August 2203 container. Okay, and let me attach it. So now if you go to the temp, you will see the file, but if you see the content of this, you will not have anything. That is because now, even though you have created the image based on this, it is only at that point of time when you created the image, whatever was available in the container, only that will be taken as a layer into the image and not like all the runtime things. Okay, so that is the difference on taking the details from the environment and using it as a new image for the going forward whatever containers that you want to do. But still, there are some ways wherein you can share between containers that I'll talk about it later. Okay, but now what I meant to say is when you create an image, only whatever the content that is available at that point of time in the container will be present inside the image, and not whatever that you have which you're going to create later in the old container will not be available in the image. Getting it? Now practically, if you see here, if I have to create this image, for example, if I have to create my, what? Oh, sorry. Now, if I had to create this image, what is that I had to do? If you see, literally, we had to first create a container, and in that container, you have to put everything and then create an image, right? So that means now to create a new image, first you have to create a container, manually go inside it, and then manually you have to install or put whatever that you have to do. So still that is an effort that you have to do, right? So like this, every time when I want to create a new image, it is not possible for us to keep on doing it manually, because if you go to the production, there might be many things that you would be doing. You might be installing some application, running some services, creating some file, running some huge scripts. Everything is possible because container is going to be like a new operating system. So it is not simple environment what you will have in your production. You will be having so many things. So will it be easy for us to do all this task and create a image? Now practically it is not possible to do it manually when you have a complicated image to be created. So that is when the next topic that we are going to create or work on is going to help us. So that is called as Docker files. Okay, so now there is a concept called Docker file. So what is Docker file? Now Docker file is a file, again, which the Docker will understand. And what is the purpose of this Docker file is, you have to give certain instructions in this Docker file, and from this Docker file you can create a image. That means now when we use this Docker commit, what did we do? From an existing container, we created a image, right? So instead of doing this, what we can do is we can create one file, okay, and I can call this file as a Docker file, and here I will give certain instructions on what and all is my new image going to contain. So in that case, now here if you look, I'm going to say the same thing, that is, for my new image, you cannot create a new image directly, because to create it, it always has to be from a container. Now, here, I'm not going to create a container manually. So instead, we will write the instructions in the file. So whatever you write the instruction here, when you give this file to the Docker, Docker will read the instructions from this file line by line, and based on that, it will create one container and it will try to execute whatever that you have given in this file line by line inside the new container. Okay, and now based on that container, it will automatically create a new image, so that rather than we writing all those things manually and executing it inside the container manually, you can give everything to the Docker file, and the Docker file will take care of creating the container and running all the steps, whatever that you have given on this file inside the container. And finally, once you have completed all the steps or the instructions in the file inside the container, you will create a new image automatically. So here, so for that, as I said, the first thing what you will do is, when you are trying to create a container, what is the first step that you have to do? You need to tell what is the image, right? The base image. So the same way, for the Docker file, you will specify as a first step what is the base image that you have to use. And then the next thing you will say is what is the entry point that you want to have. Okay, so the next step instruction what you will do is what is the entry step or the environment that you have to create, and then on top of that, whatever that you want to do, like you want to create a file, you want to run a script, you want to install something, all those steps, whatever that you want to do, you will specify it inside this file, wherein there are specific ways to give the instructions inside this Docker file. And now when you give this file to the Docker and you tell to the Docker to build a new image, what Docker will do is on the back end, it will first create a container. Okay. And inside this container, it will try to run all the steps, whatever that you have given. Okay. And once it is completed, then from this particular container, it will create a new image. Okay. So it will create a new image, or you can say it will build a new image. And on that new image, you will be having all the steps, whatever that you have done inside the container. That is, you will have the base image, and then you will have some entry step, whatever you have given, and then whatever steps you have to done. So this way, you can automate the creation of the image using Docker file, or you can build an image from the scratch automatically using Docker file. Okay, so that is what the next thing that we are going to do. Now, to just give an introduction for today, because there are lots of options that is available in the Docker file, and for every specific step that you want to do, you have to use a specific instruction, and there is a syntax for it. Syntax is nothing but, in the technical term, it is a way that you have to give some string so that it will be identified specific to Docker. Okay, now that is what you have to do. Now, whenever you are creating a Docker file, always make it as a standard to create the name of the file as Docker file itself. It is because by default, the Docker understands this file itself. So you don't have to specify what is the name of the file where you are giving all the instructions. So let it be only this Docker file. Okay, now let me quickly show you an introduction. So now, where am I? I'm inside root. So let me go inside a folder. Okay, so I'm inside a folder called home user. Okay, I'm going to create a folder here called Docker. Okay, so I'm inside this folder called home user Docker, and you don't have anything inside it, right? So let me create a file called Docker file. Okay, and I'm creating the file. Now, once you open the file, you have to give the instruction. And now to give the instruction, the very first thing that we need to give is what is the base image that you are going to use. Okay, so again, the base image can be a scratch image which the Docker gives us, or you can still use an existing image of what you have. Anything is possible. Now, in order to specify that, the first syntax that you're going to use is this word called from. Okay, so you're going to say from and the image name. This is what you're going to do. Okay, and now what will this do? So when you give this instruction, whenever you are running this Docker file, then Docker will create a container using this base image for that container. Okay, so the first line that you have to specify in a Docker file is from and the image name. Okay, now that is what you're going to do, and then I'm going to run some command inside it. Okay, so let's not worry about all those things. Simply for your demonstration, I'm going to use one more instruction called run, wherein run is a syntax using which whatever command that you want to run inside the container, that you can run it. Okay, now what I'm going to do is the same thing. So I'm going to say temp test file. Okay, so what will this run do is it will create a container with whatever base image you have, and inside that container it will run this command. Okay, so it is like how we are going to run it manually. This is going to run it automatically. So that run is a command or an instruction which is given for the Docker file to tell that you go to the container and run this command whatever you have given, wherein this is the option for this run syntax. Okay, so let us do that. So now I'm going to say the same. So I'll say from Ubuntu. Okay, so you can say that. Okay, let's keep it proper. Okay, and now the next thing is I'm going to run. So I'm going to simply say run touch test file. Okay, so any command that you want to run, you can run. I can say this, or simply I can say echo and dummy. I'm just going to print some word called dummy inside this file. Okay, so what is that I did? We created a Docker file with the base image called Ubuntu, and inside that we are going to run one command called echo dummy. So what is this going to do? This will create a file called test file, and inside that it is going to put some line or content called dummy. So I can show you that. Okay, so you see, you will create some file. So that is what I'm going to do it inside the container. Okay, so now once you have created this file called Docker file, how do you create an image based on that? Because here, if you remember, we have to build an image. For that, it has to do these two things. So how is that we can do? So in order to do, we have to use a command called docker build, wherein you are going to build a image from whatever the Docker file that you have. So for this, what is the option that you have to give is, so you have to say docker build, and then for the build, you have to give two things. One is what is the Docker file which has the instruction, and what is the image that you are trying to build from this Docker file, right? So for that, we will use an option called -t, which is nothing but the tag or the name of the what image. So there I will say my image name, okay, that you're going to create, and followed by what is the name of the Docker file. So simply, as I said, by default, Docker will understand the name of the Docker file as Docker file itself. So all I would say is say a dot here. Dot means in my current directory, check for a default file called Docker file and use it. So in case if you're not having the name of the file as Docker file and something else, then here you have to give the file name, and not just the file name, the complete path where the file is available. But now, since we are using the default name as Docker file itself, and it is going to be present in the same directory, or I am going to run this command from the same directory where the Docker file is available. So I'm going to say dot here. Okay, so that is the way. Now let us try to create the image. Okay, so I'm going to say docker build -t. Okay, and I'm going to say dfile image. This is nothing but Docker file image, just for a reference. Okay, so now from this I'm going to say dot, because we are present in the same directory as of the Docker file. If not, what is that you have to do? I have to say, what is that? Home user, what was that? Docker and Docker file. This is how you are going to specify. Now, since we are in the same directory, I don't have to give all those things. And since the name of our file is also Docker file, I'm going to simply give a dot. Okay. Hmm. What's happening? Invalid argument. Let's not worry about that. Okay, so now if you see, I just gave the name of the image as test. And now if you look closely what it has done, the first thing is it has created a container. And in this container, it is running the first step from this base image. So it has created, and then in that container which it has created using this image, it is running this step. That is the second step. Okay. And once that is run, look what it is saying. It is clearly saying that it is removing the intermediate container, whatever that you have created, because we don't need this container anymore. So what does that actually need? We need the image. So automatically, once the image, once a container is created, it will create the image also. So now if you see, do we have that new container? No, it is only the three containers what we have, because if we had done it, we had to create the container manually and do all those things, and then still the container will be there. So you have to delete it. Whereas the same thing will be handled by the Docker automatically if you use the Docker file. And the next thing, to see the image, now you see we got this image automatically. So if I want, I can use this image to create a new container. So if I say docker run -t -name, I'm going to say test container. And for this, the image is test. What happened? Docker command not found. Oof. Service docker start. Huh. Ah, my goodness. I'm inside a container. Sorry for that. Okay, so now if you see, we are inside this container called test container, which we created using this image called test that we created. Okay, so now if you go inside the temp, you will see the same file and you will see the content also. Okay, so that's the way how we can create a image from the Docker file automatically, or the second way of creating an image automatically is using a Docker file. Okay, so